bit.aspx page, and the cookie was different across all those different requests. The cookie that was different was a user ID cookie. And so what he was able to do was, it was an application that had poor authorization mechanisms. It relied on a simple user ID cookie, which was a 3-digit number. And once you could manipulate that, you looked at other people's bids, and obviously he was able to undercut them. So in this case, actually, the fact that IS6 allowed cookies to be logged really assisted us in this investigation. Moving on, the referrer header. I've always seen a lot of speculation as to whether it's a good thing to look at the referrer header, whether it's a bad thing, whether it's a misleading header, or it's actually something that's useful from a forensic standpoint. How many people think that the referrer header is useful from a forensic standpoint? I see very few hands going up. And how many think that it's not? Because I don't assume the others who didn't put their hands up do think that way. So the others are no comments. Okay, so about 6 people think that it's useful and 3 thought it's not useful. Well, the answer, I don't know. There's no right answer, and I kind of wanted to get your opinion on it, because the fact of the matter is, by looking at the referrer header, you could actually identify potential anomalies in the workflow of the application. So if someone jumped straight to the execute.asp page like we saw in the first case, that might have been detected had the referrer header not been the login.asp or one of the previous pages. But what you also have to keep in mind at the same time is that referrer headers can be fairly easily spoofed. And so if that's the mechanism you're relying on to understand how your application was broken into, you could be misled down the wrong path. So it's kind of a catch-22 situation. It's probably worth it to log it, have a look at it, but don't rely on it completely.
Yeah, I think that's the key, is when you're looking at like a cross-site request forgery or a cross-site scripting kind of attack, the referrer can be an indicator of, yeah, why is the victim coming from some other strange location? But yeah, when you're looking at something where the attacker is just beating on your application himself, he can make the referrer header say whatever he wants. So there's really nothing you can do about that. And also keep in mind, some people like to use referrer headers for session tracking, and that's not good either, because some browsers, like Opera, I think, doesn't even send a referrer header by default. There's Firefox plugins to disable referrers along with IE proxies you can use. So you can't really trust it. But it can be useful. You know, it doesn't hurt to have it and look at it as long as you don't put too much faith in it.
And then we'll just touch real briefly on URL scan. I guess it's really a defunct after IS6 is out, because they don't even recommend running URL scan, because a lot of the functionality is already implemented in IS6. However, previous versions of IIS did not have this functionality in there to block requests that exceeded a particular length, had potentially malicious characters in them. So a lot of website administrators ran URL scan, and that was a pretty good source. The log files were a good source of identifying attacks. At least Nikto scans, it kind of picked those up pretty well, if nothing else. So I just wanted to touch on that. It's probably not even valid once a lot of the people have IIS version 6 or higher running. And I'll pass it right back to Chuck.
Yeah. Just going to go real quickly over Apache. I mean, basically, Apache logs roughly the same stuff as IIS by default. It does seem to have more configuration options with other stuff that you can log. But the key really in any of this logging, especially when we get into the application servers, we're going to move really quickly, is it's a matter of, we want to make sure that you guys have some familiarity with what can be logged, and then just know the right questions to ask the system administrators. Because a lot of times the system administrators may not even realize that some of these things are being logged. So if you just point them in the right direction, then that can be helpful. And, but otherwise, typically they are going to know, hey, this is all the log files that I have to rotate every month or whatever. So they're going to know what it is. So as long as you ask them for it, that's the key really, is when you're responding to the incident initially, you need to get all those log files right away, because some of them get overwritten pretty quickly. So with Apache, I kind of just mentioned that. The two main ones are the access log and the error log. The access log is really what's going to have the HTTP request, which is similar to what you saw in the IIS logs. Error log is more if Apache has errors, you'll see stuff. The file names are a little different on Windows or Unix. And some modules, especially mod rewrite, if you're using that, has its own log that can be useful for perusing as well. So this is the default log format line that you'll see in your httpd.conf. Basically, it's logging those things. It's pretty much, like I said, the same thing that we saw there. You do get the number of bytes by default in Apache, which is kind of nice. It even tries to use identd, which is kind of surprising that it still tries that, but typically that's going to be nothing there. And mod log config is what will basically allow you to do a lot more of the configuration of your logging. And it does have the option, I believe, to do your post parameters where you can capture those as well. It's just we haven't seen it actually being used, unfortunately. So that's a quick and dirty over Apache. So now I'm going to talk for a few slides here just on different application servers. So we're moving back, basically, if you remember back to that original diagram, we've talked about the web server, which is typically what's handling the initial SSL negotiation and requests from the client. And now we're to the application server. So it's what's really doing the dynamic content as far as building pages and that kind of thing. The web server will handle like images and style sheets and some of that kind of stuff. Application server is what's really building the dynamic content of the application. So the applications will log various data. The application server itself doesn't log a whole lot because there's not a whole lot that it can log. I mean, it doesn't connect to the user, so it doesn't really have that kind of information at that level. Especially like if something like HTTP authentication is being used, that's handled typically at the web server level. And if typical, more like form authentication is being used, that's handled at the application itself. So it's kind of in the middle, but it does have the ability to log basically things that the application didn't take care of. So if the application throws an exception that doesn't get caught anywhere, then that will get logged by the application server. If there's any sort of loader problems where a class is referenced that isn't available, that'll get logged by the application server. And some other implementation dependent stuff. The application server also handles basically redirecting the standard output and standard error of the application to log files that then you can look at later. So the application server, we're going to go through a couple examples, is basically, it's off-the-shelf software. So ASP.NET is, of course, the most common one. It doesn't have its own log files where it'll basically throw stuff into the Windows event logs. And one of the interesting things is .NET 2.0, it will actually halt the application if there's an exception that's not handled. So that's a good thing, I guess, in the sense of when you're in QA and those kind of things, it's good to detect those bugs early rather than try to muddle on through it. But of course, it is a potential denial of service in that sense. It'll restart the application, but it just takes a while. So WebLogic is the most common Java application server that we see, and it has a variety of logs. I'm not going to read through all these slides. Like I said, these are more for your reference, but it's logging basic stuff from the application server level, at least, not from the application itself. And it also has kind of its own Apache, kind of modified Apache build that it's included with it, and it has a lot of administrative stuff. And there's also a lot of kind of miscellaneous stuff that may be added if you're using some of the other Java transaction and database stuff that might be there. And as I mentioned before, your standard output, anything the application writes to standard output will get redirected. And WebSphere does essentially exactly the same thing, it just puts them in different places. So that's basically how that goes. And unless anyone has any questions on that, like I said, we're moving quickly through the dry slides so we can get to the more interesting stuff. So I'm going to pass it back over to Rohit to go through another little case study.
Okay, I'm back.
How are we doing on time, by the way? We got till half after, right?
That's right.
So
I'll leave about 15 minutes for questions.
Yeah, we're doing okay, but.
So this is another case that we dealt with where a CEO of a retail organization received an extortion threat. This is fairly common these days, requesting $250,000, and the threat was the fact that the attacker potentially had about 125,000 customer credit card numbers for that retail organization. How would you respond at that point? What did you think the CEO wanted to do? You want to make the payment, right? Yes. You want to make the payment. We have a Boy Scout there. Right. Sure. So there's definitely people who wouldn't make the payment and who would make the payment. There's a lot of factors that go into that decision. I guess, business factors overplaying technical excitement of actually investigating the case. But in this particular scenario, we had some pretty seasoned negotiators involved who were able to buy some time from these extorters, a mere 72 hours. We were called in to perform a quick and dirty forensics assessment, if you may will, to try and determine if there's a way to figure out who it is and to stall it in those 72 hours. So our job was to kind of figure out how the credit card database might have been compromised if it was a computer security breach, and if there was a way to determine who the attacker was. That's an interesting question. How did we know that they had the actual credit card numbers? In the snail mail that was actually received, they had an excerpt from the database. That kind of indicated that they did have valid credit card numbers in there. They could have been obtained any which way. We were just in there to see, was there a way that they could have, was it phishing, was it SQL injection? We didn't know at that point how those credit card numbers were compromised. But the fact that they said it was 125,000, we had initial doubts that actually 125,000 people fell for such a phishing attack. Shouldn't we report that to law enforcement? I'll leave that as an open question. How many people think that should be reported to law enforcement? Right. So here's an interesting point. Some states require you to do that. Others do not. It depends on where the company is based out of. When it's based out of the Bahamas, it's kind of hard to enforce any such laws on them. I'm sorry? Right, and then there's the gray issue of, some people might say it's only a thread. We got an excerpt of 6 valid credit card numbers in there. Was it a phishing attack that actually targeted end users and not their systems? Is it their responsibility? There were a lot of gray areas in the legal issues. To be frank, at that point, given that we had 72 hours, we kind of stayed out of that and said, we're going to go ahead with what we're tasked out here for, is to determine from a technical standpoint how they might have been compromised. Yes? Absolutely, that was definitely a part of the decision. That was definitely a part of the process was, yes? That's right. There's definitely a lot of factors that go into making such decisions, and I'm just reiterating, we walked in there, we said, okay, we're tasked out, we're overwhelmed, 72 hours, we're just going to keep going at this application, keep looking at all your infrastructure, you guys deal with the legal issues there, the whole legal team taking care of that. So actually what we did is, we did what's up on that slide. We performed some frenzied web server log analysis, like I said, looking for attacks like I talked about prior to that, looking for SQL injection type of attacks. Again, the fact that there was no post data logged in there, it was kind of hard for us to say whether SQL injection might have occurred or not. We didn't see any evidence of that being performed. We also looked at employee emails, went through those, scripted up stuff to see if there was an insider who was leaking out these credit card numbers. Just looking at it very briefly did not reveal any such activity. We then said, well, let's look at database server logs. We asked the database administrator, do you log anything on your database? He said, I run Microsoft SQL and I have full logging turned on. Well, full logging turned on meant that login and log out activity were logged. That didn't really help us because all we saw was logins from the application server hitting the back-end database. So it really didn't help us there at all. We then went on to say, okay, well, we just had to kind of, it was a shot in the dark. We said, it seemed like from our past experiences that it looks like it might have been a SQL injection kind of an attack given the magnitude. Let's just try and scan this application real quick with some sort of automated scripts to figure out if it's susceptible to SQL injection. No luck. So at this point, the last resort was, I want to look at that source code quick and dirty. Obviously, there's millions of, or I guess thousands of lines of source code. It's not possible to go through it in a comprehensive manner in 72 hours. But that was our last resort. Let's have a quick and dirty look at the source code. So a comprehensive code review was obviously ruled out. We were up against a time bomb. And we resorted to some sort of scripted searches looking for some basic vulnerabilities in there.